Well, question number 9. For a given reaction, A plus B gives C plus 2D. Experimental results were collected for 3 trials and the data obtained are given below. Please read the question properly. And here it is given a big table which contains trial numbers, molar concentration of A, molar concentration of B, and rate, initial rate. Let it be rate. They did 3 experiments. First experiment they did by taking molar concentration of A is 0.4 molar, B is 0.2 molar. For that, the rate is 5.5 into 10 power minus 4. Similarly, second experiment also they did by taking 0.8, B is 0.2 and the rate is 5.5 into 10 power minus 4. Then experiment 3, we have taken 0.4 and the rate is 2.2 into 10 power minus 3. Is that it? And the question is, the correct rate law for the reaction is 5 options are given. 5 options are given. In each option, see, rate is equal to K into A into B. Molar concentration of A into B is same everywhere. Only change is that power 0 to 1 to 1 1 1 0 0 1. Now, which one is the correct option for this type data given? By using this practical experimental data, we need to find out the correct option. What is the power and what will be the order we will going to calculate. This experiment can be solved in 2 methods. In order to find out the data, I will solve in 2 methods. First method is like how we are going to solve in the regular class, and the second method is very helpful, which will be used only in the NEET and JEE, only in the competitive level examinations. We will go for the second method in order to save the time. It is 1 or 2 problem. When you solve, you will get the complete idea how to solve when data type of questions. Come on, listen here. So, the same table I have taken. We need to find out what is the correct rate law. Now, write down the rate law. Rate is equal to K into molar concentration of A and molar concentration of B. Now, what to find? To find its power. Its power, right now we don't know. Let it be X and its power is Y. Its power is Y. Now, we will apply this equation for the first experiment. We will apply this equation for the first experiment. Okay. Now, when we apply this experiment for the first expression, we will get rate. Instead of rate, we write down rate for this is the first experiment we are doing, first trial we are doing. Then 5.5 into 10 raised to minus 4 is equal to K is constant, let it be. Molar concentration of A is 0.4, power we don't know, still we don't know, and molar concentration of B is 0.2. Or else you can write down in the square bracket since these are the values. Okay, you can write down in this type of brackets, and it is Y. It is Y. Similarly, you write down for the experiment number 2, same rate, and for experiment 2, you can write 5.5 into 10 raised to minus 4 equals K is anyhow it is a constant value 0.8 power X and 0.2 power Y. Similarly, for the third experiment, we can do rate is 2.2 into 10 raised to minus 3 is equal to K into its concentration, molar concentration of A. Same thing we are applying 0.4 power X, 0.4 power Y. So much we got. Now how to solve this thing? Further, this is experiment number 1, experiment number 2, experiment. It's very simple. Divide experiment number 2 by experiment number 1. How to do it? Let's divide trial number 1 or experiment number 1 or 2 by 1. 2 by 1. I will use the different color. Now, when we do 2 by 1, we got something like this. 2 is 5.5 into 10 power minus 4 divided by 5. Experiment number 1, 5.5 into 10 power minus 4 equals k is constant for k into 0.8 divided by 0.4. I can write now like this x, because both are x. This simple mathematical steps. Then 0.2 upon 0.2 over y. Now this will get cancelled. What is that? 1 is equal to k by k. It get cancelled also. K by k. Okay, it get cancelled. Then 2's are 2 power x. Then it is 1's are power y. Okay, and it is a constant. Then it is neglected because 1 power something is 1 only, so that it is neglected. Then 1 equals 2 power x. Now, if something power 0 is always equal to 1, then I can also write 2 power 0 is equal to 2 power x. So 2 bases are same, then its power x is equal to 0. We got to know the value of x must be 0. So x is 0. Clear? In this way we calculate it. In the next method, we will go for now experiment number 3 by experiment number 2. Experiment number 3 by experiment number 2. Okay. Experiment number 3 by experiment number 2. Or else we can also solve in this method, this also divided by this one, or anyhow you can easily come to know. Then this by this 3 is almost 2.2 into 10 power minus 3 divided by 5.5 into 10 power minus 4 is equal to, this is k constant 0.4 power x upon 0.8 power x is equal to, or into 0.4 power y, then divided by 0.2 power y. Or simply we simplify this. Okay, how much you will get here? Here you will get this. I can solve this 2.2 to 22.4. Almost you will get the value 4. You will get equals. This is k. K get cancelled. Then what is that? This is x. So 1 by 2 power x. Then this is nothing but 2 power y. 2 power y. So how to write this? This can also be written as 4 is equal to 2 power minus 1. So and 2 power y x. Since we know that the value of x is 0, the value of x is 0, 4 is equal to 2 power minus 1, it will be 0 into 2 power y. So it is overall power is 0, or half power 0 is always equal to 1. So 4 is equal to 1 into 2 power y, or this 4 can also be written as 2 power 2. Here I write 2 power 2 is equal to 2 power y, then y is equal to 2 2. Then we can write the rate is equal to K into molar concentration of A into molar concentration of B. Just now we calculated the value of X is 0 and the value of Y must be 2. So this is the correct answer. So we calculated the value of X and value of Y, and the correct option is A power 0 and B power 2. A power 0, B power 2, K will be constant. So option A is the correct option. Option B is correct. Clear? Now in the second method is shortcut. It is a shortcut, a tricky method. Logically you have to think how to solve this type of problems. Very simple. Now when you observe this type of questions, now carefully you see where two values must be same. Now first of all I will write the rate now. Rate is equal to K into molar concentration of A and molar concentration of B. This is X, this is Y. We don't know what is X and what is Y. Now first make A constant. Then in the second type make B constant. Now when you take experiment number 1 and 3, where molar concentration of A and A is same, that means it is constant. So how much increase? Nothing has increased. Nothing has increased, so that it is same. Same means it is constant. For when this is constant, and when you consider 0.02 to 0.4, B increases, A remains same. So when B increases, how many times increases? It increases for 2 times. 0.2 to 0.4. How many times increase? 2 times increase. So that molar concentration of B is increased for 2 times. Now for that rate is how many times increase? See here 5.5 to 10 power minus 4. This is 2.2 into 10 power minus 3. This can also be written as 22 into 10 power minus 4. So 5.5 to 22. That means how many times increases? 4 times rate increases. 4 times rate increases. Okay. Now from here to here, rate increases for 4 times. 4 rate increases 4. Then molar concentration of A from here to here, molar concentration of A is nothing has increased. It is constant. Constant means we can write 1. But because it is a constant, okay, nothing has increased. Then molar concentration of B to B, experiment number 1 and experiment number 3, that is trial number 1 and trial number 3 we are considering. Then how many times increases? It increases for 2 times, power Y. So power Y, so we know that it is 1 into power is 1 only, so 4 is equal to K into 2 power Y. K is also a constant, then 4 can also be written as 2 power 2 is equal to 2 power Y. Then Y is equal to 2. We got the answer, Y is equal to 2. Now write down Y is equal to 2. Okay. Then in a second, see, I observe carefully the problem where B must be same. The molar change in the concentration of B must be same. So here in the experiment number 1 and experiment number trial number 1 and trial number 2, where B is constant, A is changed. A is changed. Don't worry about the rate, just see this changes. Then trial number 1 and trial number 2. Rate, how many times increases? Rate, nothing, 1 time increases. 1 time. So rate equals molar K into molar concentration of A power X and B power Y. B power Y. How many times rate increases? When you compare 1 and 2, rate nothing else increases. So 1 equals, or simply you write down 1. Simply 1 is equal to K into molar concentration of A. How many times increases? 0.4 to 0.8. How many times? 2 times. 2 times increases 2 power X. Then B, how many times increases? nothing has increased, same constant number, we will write 1 power y. So 1 is equal to 2 power x, because 1 is constant, k is also constant, something 1 power something is always equal to 1. Then see, this is what I can write, 2 power 0 is equal to 2 power x. Then bases are same, your 2 power 0 is always equal to 1, then x is equal to 0. So this is the shortcut method we will be able to solve. So x is equal to 0, y is equal to 2, then straight away we can write x is 0, and you can see this is the correct option now. By using this method also, you can tell this here, rate is equal to k into a power 0 b power 2, molar concentration of b power 2. The correct option A. In both the methods you can solve. I hope the second method is quite easy method, logic based, only small trick is required. So the second method is a shortcut method, but you should not use this method in the board exam. Okay, you have to go for the previous one only, but in the competitive level, in order to save the time, you can use this method. This is the shortcut method where by simply watching the data you can calculate this type. Okay, so how this 4 comes, don't get confused. How this 4 comes, when we compare 1 and 3, this is 5.5 10 power minus 4, this is 2.2 10 power minus 3, that is nothing but 22 into 10 power minus 4. When you see from here to here, this and this is 4 times bigger when you compare to this one, so that I have 4. Then here, then molar concentration of A, 1 and 3 is constant, so I get 1. Then 0.2 to 0.4, B is increased for 2 times, so I have written 2 power y. Then 4 is equal to k into 2 power y, or 2 power 2 is equal to 2 power y, y is equal to 2. We got like the answer like this. Then when you compare 1 and 2, how you selected 1 and 2? Where you are making B as constant. Here we made A as constant. When you make B as constant, molar concentration of B is increases only 1 time. That means it is constant, and A increases for 2 times, 2 power x, 1 power y. So rate, no change in the rate. So rate is constant. If it is constant, then you can take 1. Then 1 is equal to k into 2 power x, 1 power y. Then 1 is equal to 2 power x. So 2 power 0 is nothing but 1. 2 power 0 is equal to 2 power x. Bases are same, then x is equal to 0. Clear? This way you can solve this. Question number 10. Read the question. Which one of the following is wrong about molecularity of a reaction? You need to select which one is the wrong. Which one is not matching with the, which one of the following is wrong about molecularity of a reaction. Okay, this is the question. 4 options are given. It may be whole number or fractional. It is calculated from the reaction mechanism. It is the number of molecules in the reactant taking part in a single step of a reaction. Of course, definitely C is direct definition of molecularity. It is true. It is always equal to the order of elementary reaction. This is also true because molecularity is applicable only for the elementary reaction. It is applicable for the elementary reaction. In the elementary reaction, order and molecularity both are same. It is calculated from the reaction mechanism. Definitely yes, it is also calculated with the reaction mechanism where it is applicable for the single step and elementary reaction. It is a whole number. Definitely it is a whole number, but it is not fractional. It is not fractional. Here it is given wrong statement. It may be a whole number, true, but it is not applicable. It is not a fractional. It is always a whole number, so that it is not a fraction. It is not a fraction. Okay. So option A is wrong statement for the molecularity, where it is not a fractional. It is whole number, but it is not fractional. It is not applicable. So answer is this one. Correct option is this one. The wrong statement given for molecularity. Then let's move on to the next question. Question number 11. Question number 11. Which of the following statement for the order of the reaction is incorrect? Which one is incorrect for the order? Which statement is not at all holds good for the order of a reaction. Let's see the options now. Now the options are given. It is just memory based questions. Order can be determined only experimental. True. It is true. Order can be determined only by the experimental since it is an experimental value. Order is not influenced by stoichiometric coefficient of the reaction. Definitely yes. Order depends only on the rate law. Whatever given is not at all applicable. Then order of the reaction is sum of the powers of the concentration terms expressed in the rate law. Yes, when order comes only in the rate law, definitely yes. True. Option A is also true. D is true. C is true. Let's see the D. Order of the reaction is always a whole number. No. Order of the reaction, it may be whole number, it may be zero, it may be fractional. It applicable for all also. Okay. It is not only here it is given always whole number. Sometimes it is a whole number. Sometimes it is a fraction. Sometimes it is zero also. Non-integer. Zero value also it will come. You will get it. So option D is correct option for the question number 11. Clear? So the question number 12, it is related to the first order reaction. The first order reaction is specific rate constant. Rate constant K is given 10 power minus 2 per second. How much time will it take for 20 gram of the reactant to produce 5 gram? 20 gram ತಗೊಂಡಿದ್ದಾರೆ ಇನಿಷಿಯಲ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ 20 ಗ್ರಾಮ್ 5 ಗ್ರಾಮ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ 20 ಗ್ರಾಮ್ 5 ಗ್ರಾಮ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ತದೆ? How much time is required? Now let me solve in this way. Again I will solve this in two methods. One is regular class method. There is a to B. In this reaction 20 in the initial state 20 gram was taken. It was 0. After some time it becomes it becomes 5 gram. So A was 20 gram. Now after some time it becomes 5 gram. How much time it will take to reduce 20 gram to 5 gram is the question. Now for that rate constant K is given. K is equal to 10 power minus 2 per second. Rate constant is given 10 power minus 2 per second, and which order it is? First order. Now let's apply here. Now K is the rate constant. 2.303 by T log R0 is the initial concentration of the reactant A, and RT is the concentration left after some time T. After some time. Now it is given. Let me consider this 20 gram is R0 initial concentration, or this is RT final concentration of A after some time. This time we need to find out. Now write down the 10 power minus 2 instead of 2, then 2.303 by T. We don't know what is the value of T time. In second we need to find out log molar concentration of initial state was 20 gram by 5 gram. Then T is equal to 2.303 upon 10 power minus 2 log, this becomes log 4. So log 4 value is 0.6 approximately you can take. Then T is equal to you can write 2.3 into 10 power minus 6, that is nothing but 60. So you will get time 130 something, 130 2.303 is approximately 138 you will get. This is per second, not second. Second, by this answer is yes, it is the answer. Option A is the correct option. Option A is correct. Clear? Now let's move on to the next method, next type of method. So next method will solve in this way. This is the first method. See here, it is first method where you have to do this type of solving only in the board examination. Okay. The second type of method I will tell you. Now same problem in shortcut method, tricky method. K value is given 10 power minus. K value is given 10 power minus. Okay, it is a first order reaction. Then T half means time taken to reduce half. T half is nothing but 0.693 by K. Then T half is equal to 0.693 by K value is 10 power minus 2. Then T half is equal to 69.3 seconds. 69.3, which is what time T half. Now what is the initial concentration was taken? Initial concentration firstly 20 gram was taken. 20 gram is half of the 20 gram half of the 20 gram under 10 gram. So 10 gram in the next to 5 gram. 10 gram in the next to 5 gram. So 5 gram ನಮಗೆ ರೆಡ್ಯೂಸ್ ಆಗಿದೆ. ಸೊ 20 ಗ್ರಾಮ್ ಇನ್ಷಿಯಲ್ ಇತ್ತು, ಈಗ 5 ಗ್ರಾಮ್ ಇದೆ. ಸೊ 20 ಗ್ರಾಮ್ ಇಂದ 10 ಗ್ರಾಮ್ ಅಂದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ಟಿ ಹಾಫ್ ಆಯಿತು. ಇದು ನಾವು ಹೇಳ್ತೀವಿ 1 ಟಿ ಹಾಫ್ ಅಂತ. 10 ಗ್ರಾಮ್ ವಾಸ್ ಟೇಕನ್, ನೌ ಇಟ್ ಇಸ್ 5 ಗ್ರಾಮ್, ಅಗೇನ್ ಹಾಫ್ ಆಫ್ ದಟ್ reactant was reduced, then again it is ಟಿ ಹಾಫ್. So again it is ಟಿ ಹಾಫ್. Now from here to here total time we need to find. What is 1 ಟಿ ಹಾಫ್? 1 ಟಿ ಹಾಫ್ is 69.3. ಇಲ್ಲಿ ಎಷ್ಟು ಟಿ ಹಾಫ್ ಗಳಿದೆ? So it is nothing but 2 ಟಿ ಹಾಫ್. Okay, 2 ಟಿ ಹಾಫ್ total time. Total time 1 ಟಿ ಹಾಫ್ is 2 into 69.3. 2 into 69.3 is total time. Then time t is equal to 138.6 seconds. This is the tricky method solving technique. So 20 gram to 10 gram, 10 gram in the 5 gram, 1 टी half, then 2 टी half. Okay, this is the answer. So option 138, option A is the correct.